Okay, let's do an advanced chemical dosing problem. For those of you who are watching this video, I'm going to make some assumptions about your math skills. I'm going to assume you know the pounds formula like the back of your hand, and that you're pretty familiar with converting pounds to gallons per day of sodium hypochlorite. I will do more basic videos and link them in the description below if you want some review on those things. I'm doing this advanced math problem because a viewer asked for it, and they are getting ready to take a test that's more advanced, so I want to get this out for them. I will follow up with those more basic math problems later. So just for the steps in here, I want to tell you kind of what you're going to run into. You need to know this for your grade 1 and 2 wastewater. In your T1, I never took the T1. I skipped right to the T2, which is, I had to know this. I had to know this for my grade 3 wastewater. And down here, I needed to know this for my grade 4 wastewater and my T3 drinking water exam. So kind of an idea of, the range you're going to need to know for your exams. And this is like, and let's say New Jersey, I would expect this is going to be like a class 4. This would be like a class 2 wastewater. There's all sorts of different states do all sorts of different stuff. So just kind of use, this is more advanced, this is more intermediate, this is more basic kind of. So, okay, with that, let's move through the math problem and see what we can come up with for our feed rate for our chemical pump in milliliters per minute. The flow of our plant is 150 gallons per minute with a concentration of 12.5% sodium hypochlorite and a specific gravity of 1.2. That's our chemical. This is our flow. And this is our dose. I'm going to dose a 20 milligram per liter wastewater treatment plant dose. If you have questions about why this is 20 milligrams per liter, not like a 5 or a 10, please ask in the comments below. This is like my 4th time shooting this video, and I keep trying to explain it, and I realize that I'm missing the point of the whole math problem. So maybe when we get into disinfection, I'll talk about target doses based on constituents in the water. But if you want to know it now, message me, comment, whatever. 20 milligrams per liter, and then we have a pump feed rate of 60 gallons per day. So what are we going to do in milliliters per minute? And I'm going to take it a step further and say, if you don't have a flow meter to dial in 76 milliliters per minute, which will be our answer, what percentage feed rate do you set that pump at? Okay, so I'll explain all that when we get to it. First thing we're going to do is find our pounds per day of chemical. So we're going to take our flow rate and convert it to million gallons per day. And all that is 150 gallons per minute times 1,440 minutes in a day is 216,000 gallons per day divided by a million, which I didn't do for the sake of space. And that's 0.216 million gallons per day. Times 8.34 pounds per gallon times 20 milligram per liter dose gives us 36 pounds per day of chemical. Okay, so I breezed through that really fast because I'm assuming you all know that pretty well. Let's now go down to gallons. We need to convert those pounds per day to gallons per day. And how we do that is we take the weight of 1 gallon of water, which is 8.34, and that has a specific gravity of 1.0 when we're talking about liquids, okay? This liquid, sodium hypochlorite, has a specific gravity of 1.2. So to find the pounds per gallon, we multiply 8.34 times 1.2, and that comes out to right at 10 pounds per gallon. So to find gallons per day, what we do now is we take 36 pounds per day and divide it by 10 pounds per gallon of sodium hypochlorite, and then again divide by 0.125, which is the decimal version of 12.5%, and that gives us 28.8 gallons per day. I will go more in depth as to how that works in the intermediate math. If you have questions now, right this very minute at the posting of this video and want some more clarification of that, please put it in the comments below, and I can tell you how that works. Okay, so we have our gallons per day, but that doesn't help us. We need to spread it out through a whole day, and now I need milliliters per minute. So how do I get gallons per day to milliliters per minute? Well, there are 3.785 liters in a gallon, and there's 1,000 milliliters in a liter. So simply, we're just going to multiply 29 gallons per day times 3.785 liters in 1 gallon to get how many liters there are. And then we're going to multiply those liters by 1,000 to find out how many milliliters there are of those liters. Okay, and that's what this math problem looks like right here. And you can see I did the latter thing. I wrote them out as fractions, so you can see how the units cancel out. The gallons cancel out, the liters cancel out, and we're left with milliliters per day. So 29 times 3.785 times 1,000 is 109,765 milliliters per day, but we need milliliters per minute. So we divide by 1,440 minutes in a day. And now we have 76 milliliters per minute. That is our target chemical feed rate for our chemical feed pump. And if you are blessed with sophisticated SCADA systems with PID loops that are looking at analyzers, a lot of this is not very useful in a day-to-day plant, but they're assuming you don't work in one of those plants, and they're assuming that you actually have to do this dosing math on a fairly regular basis when you're taking these exams. The other thing that they're assuming is that, I've been in situations where SCADA shorts out, or the PLC has a problem and shuts down or burns up, or something happens, and you've got to go to paper and pen and you've got to get your calculator out. I call it human SCADA, where you're running around like the good old days, doing everything while the programmers are trying to figure out what just happened and fixing your computer program. So that's another thing about these cert exams, is they're going to assume that you can do your job without help of automation. Okay, and automation definitely has its place. It makes our lives easier, but you need to live in a world sometimes that the automation's not there to help you. Okay, so some of us don't have those cool flow meters. I don't have the flow meters. What I have to do is dial in my chemical feed pump. I use Stenner pumps with peristaltic tubes, and it's really simple. There's just these percentages that you can dial in, and I can put percentages on my SCADA system if I want with our flow-based dosing. So there's two ways to do this. There's the easy way and the hard way. So we're going to do both ways so that you know how this works out, and it's also a great way to check your work, is doing it two different ways. The easy way to find your feed rate is not even doing this at all, is finding that you need 28.8 gallons per day, and you divide it by 60 gallons per day, and that's 48% feed rate. And by the way, I just popped it to 29 gallons per day in this because it's so close to 28.8. You might have seen that, but might as well point that out. The long way is to convert my gallons per day on my pump feeder, and that is the same math that's here. You can do it for yourself. 60 times 3.75 times 1,000 divided by 1440. That comes out to 158 milliliters per minute capability of my pump. And I wrote 157 here for some reason. Sorry, guys, if that was confusing. Let's see if I can fix that. Ugh. Horrible handwriting. But so now you can see 76 milliliters per minute divided by 158 milliliters per minute is also 48%. So do this type of stuff on the exam when you want to check your work. If you get the same number by doing the math multiple different ways, that's definitely a good sign. So this is how an advanced chemical dosing problem will show up on your exam. If you want more conceptual context, we can talk about flow rate variance and dosing variance, but they're not going to do that to you on the test. It's just these doses move all over the place, especially in a wastewater treatment plant, and depending on what process is in front. And my doses range anywhere from a 2 to a 30, and I bounce back and forth on the breakpoint curve depending on what process is taking the lead and what my flow characteristics are, the influent characteristics are, and what it is I'm trying to accomplish at that point. So there's times I'll have a 2 free available dose, and there's times I'll have a 10 combined dose, or not dose, I'm sorry, a 2 free available residual in my contact chamber, and there's times I'll have a 10 combined monochloramine residual in my contact chamber. It just depends on what's going on. So this is kind of what I've recorded this video a few times, and I just keep getting wrapped around the axle about this. I think it warrants its own video, and we'll cover that when we get into disinfection on the conceptual side of the channel. Anyway, I'm rambling. Please like, subscribe, share with your friends, help grow the channel, get this information to people who need it. And if you have any questions at all about this math, please ask. I want to help you pass your test. With that, have a great day, happy studying, and we'll catch you in the next one.